Hello, I'm Shane in Sweden and welcome back to our series of videos on how to build an intrusion detection system in C#. And remember, if you want to follow along coding yourself, download the source code from the link in the notes below the video. In this video, we're actually going to start looking at capturing some live network data with SharpPCap. And to do this, we'll have to create some new tests. But first, as you all may have spotted, I think it's time to rename our test from senior tests to sensor test. So let's just fix that. Yep, we need to fix that in our class as well. So without further ado, we can start creating our test for SharpPCap. So let's add a new class. And this will be called SharpPCap Information Source Tests. Okay, and we wish to, of course, copy of our namespaces. And this will be a test class. Okay, let's create our first test. It should be a test method. And here we were going to check that SharpPCap is installed and working properly. And we'll do that by getting it to return a version number. And of course, we're going to use our familiar arrange, act, assert format. Here we'll just check the version string. Okay, we're not getting any SharpPCap information here in IntelliSense, which means that we haven't installed it. We've probably installed the package in our Tyranids. There we've got SharpPCap, but I'm guessing we haven't installed it in our test project. So let's get that done right away. And we'll check we're in the right project. We're in Tyranid tests, yes. So from our package manager console, we can install the NuGet package. Okay, so we're installed, and now hopefully we will be able to see SharpPCap. There it is. We get the version and the version string, and in our assert we can check this is not null. So we've created our first test, and let's run that. Now we can proceed. As a second test, let's just check that we're actually able to capture some network information. So let's create a new method. Let's check that devices are available to capture. SharpPCap has a class that allows us to detect which devices are available. So we need to retrieve the instance of the device from that. So we have a capture device list. And that we can get from the capture device list instance. Okay, so if we run this test, and we get an error directly, so let's look at our error message. And it says no interfaces found. Check the your libpcap winpcap isn't properly installed on the local machine. This is a very important point about unit tests. When your system depends on certain preconditions being met to work, it's quite useful to create unit tests that check that those conditions and requirements are in place, so that you don't waste time trying to work out why tests didn't work when in fact it's actually some basic building block is missing from your system. Okay, so I did a quick investigation, which is available in the last video in the series here, and I discovered that the reason I was having problems detecting capture devices was because I had moved the computer from a wired connection with an Ethernet cable to wireless. But in this project I really do want to work with some wireless data, so checked out what the problem was there, and it turns out that WinPCap does not support Wi-Fi. I was forced to install NPCap, and again you can check out that in the video. So now we've installed NPCap, and so we should be able to see if our test works now. So if we rerun our tests, and now it's green. So if we just go in and look, see what it's capturing here, see what devices are available. Just step over. And if we look at list of devices that are available, we can see there are various VMware, but we want to find our Wi-Fi device. And if you look at the network devices here, we can see we've got several different types. Okay, now we need to go on. Here we're going to create a unit test where we're actually trying to capture some network information from a WinPCap device. And we're going to actually try capture some network information. So let's try check device capture. That would be good for name. And we'll go back to our FTP example, FTP data network traffic data found. There, that looks good. Now we want to create a capture device. When we're creating a unit test, of course, we can actually just use a real capture device, such as we have seen here, Wi-Fi devices or an Ethernet network card. But generally we want to try isolate our test as much as possible from the physical world. So here we're going to try create a sort of a mock, a fake. So we'll create our capture device. And this is going to be a new test capture device. Okay, and this doesn't exist yet, so let's just create that. Now we want this device to simulate a real WinPCap device, so we're going to implement the iCapture device members. And you can see there's quite a lot of members there. We're not going to implement them all. Okay, we can now compile our test. Now, this capture device is something we're going to send into one of our information sources. So the information source will then be plugged into the sensor, and the sensor will react whenever we get information from our information source. So it's time to create a new information source, and that information source will be an information source that is dynamic and is based around PCAP devices. So we can just actually call it, since we're using SharpPCap, let's call this a SharpPCap information source. And that's going to be with a new information source, and we're going to pass different capture devices. So in our test here, we're going to capture, in our test here, we're going to send in our fake device, but of course in the real, when we're really using it, we would send in a device, for example our Wi-Fi device or our Ethernet devices that we saw on the list here. And devices quite often have a mode and a timeout, but well, we can implement timeout so far. We don't need to implement everything right away. So we have a Sharp information source, and we need to create that class as well. Okay, so that's looking pretty good. Okay, but this is a real class that we're going to be using in the future. Perhaps we can have it in the tests class at the moment, but we really want to move it. And actually, in fact, I think I'll move it right now. So let's move to its own file, and let's move that up to turn its project. Change the name, and we need to move our test class as well then. Let's remove them from the Okay, so let's go back to our test. So we created our network information source, and we want to start listening. And then we're going to assert something. Just a moment. So we created a method for start listening. Now in here we need to create a capture device. And when we start listening, we want the network device to start capturing data. So okay, our sharp information source should really inherit from our simple information source. And with a sharp device, okay, and if we go back to our test, so here we are, start to listen. And what we want to do then is we want to listen in on an event. So we're going to have an event in our information source that tells us when an alert's created. So we want to create a network alert. So let's go back to our information source. And here we're going to create an alert. So let's create that public event. Okay, so we created our event. Okay, so we have our alert. When do we generate this alert? We generate this alert when we receive a packet. So if we look at our network device, whenever we actually get a packet, what do? Well, if you remember from our simple information source, we have our message buffers. So we want to add the new message to the message buffer. And we're going to add our packet data to string. Okay, that's not very effective at the moment, but it'll do. And now we've added our information, and we can generate an alert. So we can create a new network alert. Now that we've received our packet. The question is, when is this event raised? When do we get a capturing packet? Well, when we start listening, we set our capture device to start capturing. And if we go to that method, we can see all that's going to happen here is we're going to generate an exception. And that's not what we want. We want to start capturing network data, but here we're actually just creating a test class for to simulate capturing of data. We don't want to be dependent in our test on actual real network conditions. So in our stack capture here, we're actually, instead of listening and then generating an event, we're actually going to, in our test case, as soon as we start capturing, we're going to throw an event. And so the event we're throwing here is on packet arrival. And this is the sender, and then we need to send a new capture event args. Okay, let's just create new capture event args. So what does this require? It requires a raw capture packet and an iCapture device. Well, this actually is an iCapture device, so we can, for the second parameter, we can just send this. And here we need a raw capture packet. Let's just insert this in here to fix that. Right, so we're going to create a new raw data capture, and that is created with linked layer type. So that's a linked layer type Ethernet, and then we need some data. So we need to create a new byte array, and we want to fill this with some reasonable data. Well, we were looking at FTP information. So if we go to some actual real Wireshark capture data, and if we select out some FTP information, so here we have a capture of a network, some network traffic, FTP traffic, and here we can see the raw bytes. So we can use these raw bytes to simulate the network traffic from an FTP capture. So if I just paste that in, network traffic information, we're missing something here in the constructor. If we check, right, we should have a new POSIX timeline there. Okay, so we've created a raw capture here with actual real FTP packet information, and as soon as we start capture, we simulate the arrival of a packet with FTP information, and we generate the on-packet arrival event, which we're listening to in our source. Packet arrives, it will add the information and create a network alert. So if we come back to our test, here we can just listen. And when we're listening, we can set something equals true. So we can create a bool variable called FTP capture occurred. And when we do capture something, we can set FTP captured occurred equals true, and then we can test. So if we run this test now, and the test has failed, we've got an object reference not set. I see the problem. If we go back to our SharpPCap information source here, we can see that when we capture a packet on the network, we immediately add that message and we generate a network alert. Now this network alert, this event, will only be raised if there is something subscribed to it, if this is not null. Now in our test, we start listening, which starts capturing, which generates an event or tries to generate an event, but at that point in time there is nobody listening to it. It's only afterwards that we actually listen. So if we simply move the order here and subscribe to the event before it's generated, then we should fix the problem. And indeed we get a green result. So we started to create, if only a test, we started to create a network device, network capture device we can use to test our methods. We've started to create some real data generated here, which has a real information packet. And we're actually going to look at this next a little bit more in the next video, I think, because this packet being real contains IP information and TCP information. We'll try to extract that out of it. But for the moment, we're starting to work on the real network capture using SharpPCap. And we're going to take that further in the next video. But I think for the moment we've done enough with our test we created today. So I hope you enjoyed that, and I'll see you in the next video. Thank you very much.